Robots are about to take over Perth with the launch of the Robopalooza Space Festival, created by one of NASA's senior technologists. WA's mining expertise prompting organisers to bring the two-day event down under, as plans are made to start mining on the moon with the help of robots.
For a century, mining meant people risking their lives underground or in vast open pits. It was hot, dangerous, and unforgiving work. Now that world is quietly changing. Machines have taken over, working day and night without rest. But the real shift is not that robots can mine. It is where this system is going next, and how far beyond Earth it is already moving. Australia's driverless pits.
Their robots are hailed as the best in the world, delving deeper than any before them and saving lives in the process. Now, a Brisbane-based robotics company is on the edge of a new frontier that is out of this world.
In Western Australia's Pilbara region, mining no longer begins with workers arriving on site. Operations are already underway. Massive haul trucks move continuously through open pit roads with no drivers, following routes planned, monitored, and enforced by software. These machines are not test projects. They are full-scale production systems, hauling ore non-stop, while humans supervise from remote control rooms and intervene only when anomalies appear. Australia reached this stage intentionally. Once ultra-heavy vehicles began operating without drivers, safety stopped being about individual skill and became a system-level problem. Recognizing this early, Western Australia introduced one of the world's first formal safety codes for autonomous mining in 2015, before many large fleets were even active. The logic was clear. If software replaces humans in the pit, then procedures, hazard controls, and emergency responses must be redesigned from the ground up. That early framework changed everything. Autonomy became repeatable instead of experimental. Other Australian states later introduced their own guidance focused on training, risk management, and operational integrity. Today, mines operate within clearly defined autonomous zones where machines work continuously and human access is tightly controlled. Automation also reshaped mining work itself. Successful operations are not simply buying robots. They are redesigning workflows. Routes are digitally optimized. Communication networks are built for constant connectivity. Human roles shift from physical operation to planning, monitoring, and system control. Driving becomes route design. On-site routines become remote supervision. Mining evolves into a coordinated system rather than a collection of individual actions. Australia matters because it proves one central point. Autonomy works at scale only when the mine is designed around it. Safety policy, communication infrastructure, and operating zones become part of the machine. Canada's self-driving gold mine.
We see new opportunities right across our country and our province, and we take another step forward on the road to economic recovery. Today, we're breaking ground on an incredibly important project here at the future site of Cote Gold Mine.
In northeastern Ontario, the Cote Gold Mine offers a different but equally important example. This open pit operation was designed from the start with autonomous hauling at its core. Here, the idea of a robot mining colony becomes concrete. The pit functions as a coordinated organism where trucks do not just drive themselves, they operate as a fleet. From a central control room, a small team supervises many autonomous vehicles at once. They plan routes, monitor performance, and analyze data while machines carry out the physical work. As production ramps up, autonomous trucks haul ore hour after hour with a key advantage: consistency. Machines do not tire, rush, or slow down. They repeat the most efficient path endlessly because efficiency is built into the system. This automation depends entirely on infrastructure. Autonomous trucks require constant connectivity, dense communication networks, and real-time awareness of their surroundings. Sensors allow them to detect vehicles, maintain safe distances, and stop when conditions demand it. Human-driven equipment can only operate nearby if every moving element is visible to the system. Safety is central. Every vehicle broadcasts its location. Trucks stop automatically near hazards. Workers can shut down machines within defined areas if needed. The goal is to remove humans from the most dangerous zones while keeping them in control of the system as a whole. Cote Gold also reveals a critical truth. Automation does not eliminate work. It transforms it. Some roles disappear, but others emerge in monitoring, route planning, maintenance, and network support. Control shifts from operators inside machines to humans managing machines. The colony that's already forming.
We're building the swarm robotic mining architectures to allow us to extract metals and materials from Earth, but in a completely new and different way.
Viewed together, Australia and Canada reveal a clear pattern. Mines are no longer places where humans perform every task. Humans design the rules, and machines operate within those boundaries. Routes are digital, zones are restricted. Risk is managed by systems rather than individual judgment. This is what a robot mining colony really is. Not a single machine, but an ecosystem. Trucks haul, drills follow digital plans, monitoring teams oversee maps, metrics, and alerts from a distance. The mine begins to resemble a control network more than a construction site. And once mining becomes a control network, one question becomes unavoidable. If humans can supervise a mine remotely, why does that mine have to be on Earth at all? When fleets operate inside defined zones with machine-level consistency, entirely new locations become viable. Places with radiation, places with vacuum, places where a human suit is fragile life support, and every extra minute is dangerous. Earth becomes the testing ground, where autonomy is proven under real conditions. But the logic of autonomy does not stop at the planet's surface. Mining where humans can't survive. The moon is not just distant, it is hostile. There is no breathable air, no protection from radiation, and no stable climate. Temperatures swing violently, dust is sharp and abrasive, and gravity is too weak for heavy machinery to rely on its own weight. A human miner would be slow, exposed, and constantly at risk. That is why lunar mining was never meant for people. It was always meant for machines. For decades, space planners understood that long-term missions beyond Earth depend on using local resources. Launching everything from Earth is inefficient, fuel is heavy, life support systems are fragile, and every kilogram lifted costs enormous energy. The moon already contains what future missions need: oxygen locked in soil, water ice near its poles, and raw material that can be processed instead of transported. Here, autonomous mining becomes a survival requirement, not an upgrade. Real-time human control from Earth is impossible due to signal delays. Machines must decide, adapt, recover, and continue working on their own. Lunar mining robots are built for this reality. They are not delicate research tools. They are designed to dig, push, climb, recover from failure, and operate for years with minimal intervention. They must function like workers who never leave the site because no one is coming to rescue them. NASA's robot miners.
Well, today we're working on preparing for a field test with NASA on hardware that needs to work together, in particular prospecting. How do we look for water and ice and other volatiles on the moon?
To prepare for off-Earth mining, NASA has developed robots built specifically to handle lunar regolith. This material is unlike Earth's soil. It is sharp, abrasive, electrically charged, and damaging to moving parts. Digging it efficiently requires entirely new methods. Instead of relying on weight and force, lunar mining robots use continuous low-force digging. In low gravity, pushing downward would lift the machine off the surface. To solve this, robots use rotating drums and counteracting forces to grip the ground while slowly collecting material. Scoop by scoop, regolith is gathered and transported for processing. These machines are designed for endurance. They work long hours, navigate uneven terrain, avoid obstacles, and correct failures on their own. If a robot tips over, it must right itself. If conditions change, it must adapt. Waiting for help is not an option. This is autonomy driven by necessity. The goal is clear. Regolith contains oxygen locked in minerals. Water ice can be split into hydrogen and oxygen. Together, they provide breathable air and rocket fuel. Fuel produced on the moon changes everything. It turns the moon into a refueling station, construction site, and launch point for deeper missions. This is why lunar mining robots are not experiments. They are infrastructure. Without them, missions to Mars remain costly and limited. With them, space activity becomes sustainable. The moon stops being a destination and becomes the first off-world industrial site, run by machines and monitored from afar. MDA, and the off-Earth infrastructure. Mining robots cannot operate alone. They need manipulation systems, coordination, servicing capability, and extreme reliability where repairs may be impossible. This is where MDA space becomes critical. Drawing on decades of experience building robotic systems for space, MDA applies the same fault-tolerant design philosophy used in orbital assembly and servicing to lunar surface operations. On the Moon, robots work as coordinated systems. One digs, another transports, another processes. Together, they form a functioning colony. Unlike past human expansion, this one begins with machines. Robots arrive first. They extract resources and build the foundation humans may later depend on. That reversal is the key. The world's first robot mining colony is not science fiction. On Earth, autonomous mines prove it works. On the Moon, robotic miners prove it is necessary. The colony without people. A century from now, historians may argue that humanity expanded into space not with footprints, but with algorithms. The first true off-world colony will not be marked by homes, flags, or voices in corridors. It will be defined by digital routes, machines repeating tasks with perfect consistency, and systems that operate without asking for permission. On Earth, autonomous mines proved a critical point. Mining no longer requires humans at the point of danger. Once that barrier vanished, location stopped mattering. Distance became a technical problem, not a human one. The Moon simply confirmed what Earth had already shown. If machines can work alone, they can work anywhere. This is why the phrase robot mining colony is literal. A colony does not require people. It requires permanence. It requires systems that arrive first, prepare the ground, extract resources, and sustain themselves long enough for something larger to follow. On the Moon, machines will mine oxygen, water, and fuel years before permanent human residents arrive. By the time humans set foot there, the most dangerous work may already be finished. That shift changes power itself. Those who build these colonies do not just explore space, they shape it. Resources beyond Earth will determine who travels farther, stays longer, and builds faster. Control will belong not to astronauts, but to machines and the networks that command them. We are not predicting the future. This colony already exists, born in Earth's mines and extended into the silence of the Moon. The age of human miners built civilization underground. The age of robot miners may decide where civilization goes next. If this opened your eyes to the future, like, share, and subscribe, because the next chapter of human expansion is already being written.